Good evening all. Today we shall see the last portion of the third module, that is PV systems and different types of PV systems. First of all, we shall see the general working of a PV system. We know that PV arrays are used for energy conversion. They receive solar radiations and convert that to DC power. This DC power can be stored in batteries for further use, or it can be converted to AC and given to a distribution panel and can drive our own loads, or can be connected with the electrical utility, that is grid, and sell this energy generated when the demand is low. Otherwise, we can purchase electricity from the grid also. So this is the general diagram of a PV system. Depending on the function and operational requirements of the system, the specific components required and may include major components like DC to AC power inverter, then battery bank for storage, in system and battery controller, auxiliary energy sources. For example, during night time, we will not be availing solar radiations. So at that time, there is no power generation. So in order to meet the system requirement, some wind energy systems can be coupled with this existing PV system and can generate during night time also. In addition, there will be wiring, overcurrent and surge protection devices and disconnection devices, the switches, and other power processing equipments. Batteries are used in PV systems for storing energy produced by the PV array during the day and to supply it to electrical loads as and when required. A battery charge controller is used to protect the battery from overcharge as well as over discharge. So we have the PV array, then it is given to the charge controller. It can be given to the battery for storage, and whenever required, the power can be retrieved from the battery also. From the charge controller, power can be fed to a DC load. Otherwise, from the storage equipment, we can connect this to an inverter so that we will be availing AC and can drive AC loads. The two major classifications of PV systems are grid-connected system and standalone system. Grid-connected systems are those which are connected to the utility grid. That is, whenever there is excess energy production, the power can be sold to the grid. Otherwise, power can be purchased from the grid whenever there is reduction in the generation. Then standalone systems are those which will meet their requirements by their own PV systems. There will be some storage devices along with standalone systems in order to meet the energy requirements during night time also. Photovoltaic systems can be designed to provide DC as well as AC. Can operate interconnected with or independent of the utility grid. That is, it can be a standalone system or a grid connected one, and can be connected with other energy sources and energy storage systems. So we shall see the block diagram of a grid connected system. Here we are having a PV array. Solar radiations are collected and converted to DC electrical power using this PV array. Then it is given to an inverter or a power conditioner so that power goes to AC power, converted AC power will be given to the distribution panel. From the distribution panel, our own AC loads can be driven as well as the power can be provided to the electric utility, and whenever required, whenever there is reduction in the power production, we can buy electricity from the electric utility grid. So this is the diagram for grid connected system. Standalone systems are designed to operate independent of electric utility grid. These systems are powered by PV array, and it may also use wind or any other diesel engine generator or some other arrangements for auxiliary power service. If there is, we know that during night time there is no energy generated by the PV system. So during that time, the power can be supplied by wind energy systems or diesel generator system or something like that. The simplest type of standalone system is a direct coupled system where the DC output of a PV module or array is directly connected to DC load. Since there is no electrical energy storage, that is batteries, in direct coupled system, the load only operates during sunlight hours, making this design suitable for common applications such as ventilation fans, water pumps, and small circulation pumps for solar thermal water heating systems. Then the advanced models will be having a charge controller and a battery for storage. So during night time also we can have the supply. Now we shall see the hybrid system also. These systems are powered by PV array and may use wind or engine generator or utility power as auxiliary power source in what is called PV hybrid system. So we are in general basically we will be having a PV array, then charge controller, then DC loads can be driven using that. If there is excess generation, we can have the battery and we can store it. So whenever we have to drive a DC load, from the battery we can avail the power and supply to the DC load. If we are having AC loads, from the battery we can provide power to the inverter, get the power inverted to AC and drive AC loads. If there is no power supply from the PV array as well as the battery, we can have engine generator, wind turbine or grid backup. Using a rectifier, we can rectify the power output from these utilities and store in a battery. If storage is not required, we can go to the charge controller and DC loads can be driven. If it is an AC load, the engine generator or wind turbine can directly drive the AC load. This is the hybrid system, hybrid PV system, which is little bit complicated compared to the standalone as well as grid connected systems. Matching the impedance of the electrical load to the maximum power output of the PV array is a critical part of designing well-performing direct coupled systems. Then frequency. In a standalone system, the renewable electricity generator must control both frequency and voltage. In the case of an isolated system, the renewable electricity generator must maintain frequency control because there is no option of frequency control by any other. So in order to improve the performance of PV systems, we can use devices like modern devices like STATCOM, SVC, static var, compensator, etc. So with this, we shall come to the end of PV systems, and a few more topics are remaining, like applications of PV system. We shall continue with that in the next class.